Okay, this is a Multitech smart modem, socket modem. This is a drop-in, totally self-sufficient modem that will go up to 56K or 33K, depending on the model. This application is for an interface to a Cat300DX repeater controller. And the controller has a 4800 baud TTL serial port built into it, and which is okay if you can plug directly in. I'm using a USB to 5-volt TTL interface cable that plugs right in my laptop, and I plug it right into the controller, and it goes to the transmit and receive lines, 4800 baud 5-volt TTL serial, which is okay if you're at the site, but if you're remote, what I'm trying to do is to be able to log in on a dial-in line, which is used on the auto patch. So you can do it right through the Cat300, but the trouble is you have to do it like one command at a time, and it's really easy to get lost. So I decided this was going to be the easiest way to do it. So this is a little prototype board on a Radio Shack perf board, and this is the socket modem right here. It's like 2 inches by 1 inch. That to the left is a 10-pin 100 mil spacing insulation displacement connector. So you should give you an idea of the size. That's 1/10 inch grid spacing on the board, and so we have the modem there that has the dial-up line coming into it. A voltage regulator on the board from 12 volts to 3.3, because this is a 3.3 modem. So it's got a power supply up in the upper left-hand corner here. There's the socket modem. 2 LEDs, one for transmit and one for receive, the TTL, so I can see what's going on for diagnostics. Not going to be much good at a remote site because it's nobody there to see it. It comes down, and I have a CMOS 555 timer and a CD4011 quad NAND gate chip for 2 relays. The top relay there by the socket modem is for the carrier detect. So when I dial in, the remote modem answers and produces a carrier detect. When that happens, the transistor just to the left of that top relay drives the relay and provides a ground to the dip switch 8 wire, which is used, it has to be grounded for remote programming. At the same time, the edge is detected by an exclusive OR gate, which is created on that 4011 IC, and it's got an RC delay on one input, so that if it transitions from a low to a high or a high to a low, it still generates a pulse that is capacitively coupled to the 555 timer to trigger the timer for about a 1-second cycle on the power. So it interrupts the 12-volt power to the Cat300 in order to have it re-look at the dip switch settings. It's the way it's built in. So the sequence is you dial in, it answers, establishes the 4800 baud connection. The carrier detect triggers the relay, which grounds the pin 8 dip switch, which is always left open, and cycles the power to the Cat300 through the second relay for 3/4 to a 1 second. So when the power comes back up, it looks and sees that the dip switch is grounded, it's in program mode, and then it outputs from its internal processor connected on my home computer. So now I've got the connection. I can download the binary file for the programming and then change what I want, and then dial back in, reverse the process, and upload it back into the Cat300. So I'll demonstrate what we got here. We got two LEDs over here. Let's see if I can get my finger here. Right? Okay. This green LED right here shows the connect status. That's the carrier detect. And then this yellow LED here is what shows that it's in power cycle. So it's a very brief blink on it, which shows you that the coil's energized, which opens the normally closed contacts of the relay and cycles the power feeding the Cat300. So let me establish a connection here. So this is my desktop. So I'm going to establish, I have a dial-up. This is directly connected computer to computer right here. Actually, the two phone cords are connected with a resistor and a capacitor hooked to the power supply to simulate the loop from the telephone company. So you have to have current in order to drive this. So let's start with a dial here. ATD for dial. Okay. Now on my laptop here, I will answer ATA. You hear the... Now we'll watch the cycle here. It's establishing the connection. Okay, the top green LED is on. That shows that the connection is there, which provides the ground for the dip switch. And you saw the bottom LED cycle for a second and go back off. So that was the interruption in the power. And we are, let's see here, we are connected at 4800. And let me I'll do, because it's desktop, I'll put D's here. And on the laptop, there's my D's there. So, laptop, I will type L's. And we have our L's over here. So we are connected 4800 baud. So, we are good to go here. This is the time when I'd be downloading the file, hang back up, decide what I need, recode it to the binary from the editor program to the binary, dial back in, establish the connection, and upload the new file to it. So let's. I will log off this connection here. So let me see here. To do that, I have to, on my local computer, I have to do Shift +++. And I got OK. Now, AT H0 to hang up. All right, now. That was our power cycle, and our ground is off, and we are back operating normally. So, this is the Multitech Socketmodem, which you can get from Mouser and other companies for about $16. I suggest going with a 5-volt version rather than 3.3, unless you really love 3.3, because it's an additional hassle in order to create that voltage. And there is no way that you can run it directly 5 volts. The only interface issue is a 1K resistor in line with the receive data coming in from the CAT to the modem, socket modem, because the CAT is outputting 5 volts. You do not want to put 5 volts directly into the 3-volt socket modem, so you just put a 1K resistor in line with that, and that's the only interfacing issue you've got other than the 3.3 volts to drive it. So, Multitech Socketmodem, working really well, and I'm looking forward to the next week maybe getting into the site and interfacing it and trying it out. So, more later as we do it. Bye.